In Module 3, Lesson 21, we're going to look at surface area. In the opening exercise, they ask us on the provided grid to draw a net representing the surfaces of the right rectangular prism, assuming each grid line represents 1 inch, and then find the surface area of the prism by finding the area of the net. So I've drawn the net and labeled the net, and it appears as if student material may or may not have a picture of the right rectangular prism. The prism's measurements are actually 3 by 4 by 6. So it's 3 across, 4 deep, and 6 tall, just so that you can relate to what we're talking about. Now what we're asked to do is find the surface area of the prism by finding the area of the net. And what we're going to need to do, hopefully you can see that, is we're going to need to find the areas of a number of rectangles and add them together. Now looking at the net, I would say the easiest thing would be to find the area of this large rectangle and then the area of these 2 smaller rectangles and add them together. So the area of the large rectangle it is 3 by 20. And that, of course, is 60 square units. And the 2 smaller rectangles are actually the same measurement. So we have rectangle 2, which is 6 by 4. Which is 24, and we need to multiply that times 2 because we have 2 of those. So that's a total of 48 square units. And then altogether, we have 108 square units, which is our surface area, the area that the outside of the prism takes up. Oh, I'm sorry, these are actually inches. So inches squared. So surface area is really just the area of all of the surfaces, the outer surfaces, of a 3D object, a solid. Now the formula for surface area of a rectangular prism is we have 2 front rectangles, 2 top, bottom rectangles, and 2 side rectangles. So the surface area then would be 2 times the length times the width. That would be your top and bottom. 2 times the length times the height, and that would be the front and back, and 2 times the width times the height, which would be side to side. Okay, so our normal surface area formula would be 2 times length width plus 2 times length times the height plus 2 times the width times the height, because it is made up of 6 different triangles, or 6 different rectangles. Now in exercise 1, Marcus thinks that the surface area of the right triangular prism will be half that of the right rectangular prism, and wants to use the modified formula, surface area equals 1/2 times the formula for the surface area of a rectangular prism. Do you agree or disagree with Marcus? And you'll need to draw some nets to support your argument. So in our drawing, we have a right rectangular prism, or I'm sorry, a right triangular prism. And the net of the triangular prism has one less face than the rectangular prism. It does not have the 4 like the other. So the two rectangular faces of the triangular prism, these two, are the same size, exactly the same size. The areas of the triangular bases, 3 and 4, are half the area of their corresponding rectangular faces. And so these 4 faces of the right triangular prism make up half the surface area of the right triangular prism. But the 5th face would be in addition to half. The 5th face is in addition to half of the surface area, so Marcus is not correct. Because 1, 2, 3, 4 will be half of the surface area of the rectangular prism, but we haven't even considered this face. So let's look at example 1, the lateral area of a right prism. A right triangular prism, a right rectangular prism, and a right pentagonal prism are all pictured here, and all have equal heights of h. They all have the same height. We need to write an expression that represents the lateral area, lateral meaning side, of the right triangular prism as the sum of the areas of its lateral faces. So in the triangular prism, each of these lateral surfaces, and there are 3 of them, so 3 times the measurement of the lateral face, which is actually h times c. So 3 times hc will be the area of the lateral face. Oh, let's make a correction here, because not every lateral face has the same length. So scratch that. Let's go back and make a correction. We would have c times h plus a times h plus b times h. Showing the sum of the areas of its lateral faces. Then they ask us to write an expression that represents the lateral area of the right rectangular prism as the sum of the areas of its lateral faces. Again, h is our height. So we would then have a times h plus b times h plus another a times h plus another b times h. Next, we want to write an expression that represents the lateral area of the right pentagonal prism as the sum of the areas of its lateral faces. So we'll do A times H plus B times H plus C times H plus D times H plus E times H. And then we're asked the question, let me just bold these so we can see our answers. We're asked what value appears often in each expression and why. And obviously H appears frequently. And H appears because each prism has a height of H. Therefore, each lateral face has a height of H. Then we're asked to rewrite each expression in factored form using the distributive property and the height of each lateral face. So we're going to factor out the height using the distributive property. And I'm going to do that in the space where we put the original expressions. So for the right triangular prism, I'd factor out the H, and it would be H times C plus A plus B. And then for the rectangular prism, I would have H times A plus B plus C. No. A plus B plus A plus B, which I could rewrite as H times 2A plus 2B. And then for my pentagonal prism, I would write H times A plus B plus C plus D plus E. And then question F asks, what do the parentheses in each case represent with respect to the right prisms? And the parentheses, the stuff inside the parentheses, represent the perimeter of the base. If you look at our triangular prism, you'll notice that C plus A plus B is the perimeter of that base. The rectangular prism, 2A plus 2B, is the perimeter of the rectangular base. And the pentagonal prism, A plus B plus C plus D plus E, is the perimeter of the base. So the parentheses represent the perimeter of the base. And finally, they ask us, how can we generalize the lateral area of a right prism into a formula that applies to all right prisms? And so we can say that the lateral area, LA, is equal to P, and we're going to use a capital P in this case, which stands for the perimeter of the base. And I'm going to put that as a subscript, so we remember that, times the height. So for all right prisms, the lateral area, and that's the side area of the surface, is going to be the perimeter of the base times its height. In reviewing the vocabulary, a right prism is one in which the sides, the lateral surfaces, are at right angles to the base. So it's not tilted sideways one way or the other. Remember, cubes, surfaces, those are the outside spaces, and the net is a two-dimensional diagram of the surface area, or the surface of a prism. The net is if you can take a box, for example, and open it up and lay it flat. And also in our review, the lateral faces of right prisms are always rectangular regions because along the base edge, the line segments are always perpendicular to the edge. Remember, in a prism, there are two bases, the top and the bottom. So there's the same shape on top as there are on bottom, and it's the same size, so that makes it a rectangle. A right prism whose bases are rectangles is a rectangular prism. And that means that the definition of right prism includes the interior of the prism. In other words, the base, the top and the bottom, is the shape that gives it its specific name. If the base is a triangle, it's a triangular prism. If the base is a pentagon, it is a pentagonal prism. But the lateral surfaces are always rectangles.